right, this is Honors Algebra 2 Pre-Calc, section 6.5 in Pre-Calculus. We're talking about the nth roots of a complex number on page 455. So again, this is a use but don't memorize formula. To the extent that I literally do not know this formula, and I do a lot of math. If I ever needed this formula, I would use the Google or some other forms of interwebs, or I would look it up in a textbook. So it's okay if you don't know this. It would be weird if you memorize this unless you're going into a really specific branch of math where this is what you need. For any positive integer n, the complex number z equals r times the cosine theta plus I sine theta has exactly n distinct nth roots given by this crazy formula. So the nth root of r times the quantity cosine of, and then this big crazy angle, which is going to be theta plus 2 pi k over n, and it's going to be the same one in the sine, which I then also forgot a parenthesis at the end. Cool. Where k starts with the number 0 and then works its way up until it is 1 shy of whatever n is. For instance, if you want the 10th root, you would go up to 9 here. So there end up being 10 numbers here because you start at 0 and you go 1 shy of whatever n is. So we're going to find all of the 6 roots of the number 1. Which is it's the exact example 7 that's also in page 455 of the textbook, because again, this is a fairly obscure formula and I'm not going to reinvent the wheel here. So the first thing we need to recognize is that 1 actually is a complex number, right? If you picture 1 as a complex number, it is a real component of 1 and an imaginary component of 0. So essentially, it's 1 unit in size, and the angle you're looking at, if you picture graphing this is right here at 1, 0. So the angle you're looking at is 0. So this is cosine of 0 plus I sine of 0. And you could make that 0 with degrees or 0 with radians. I'm going to go with radians because I'm lazy, and it means I don't need any notation. Plus, radians are just generally easier. Also, the reason I picked radians here is this 2 pi? Is it 2 pi because you're using radians? If you were in degrees, you'd be using a 360, which is not what the formula says, so we need to be mindful that the theta here is in radians, so we should be using radians, right? Okay, so then I'm just straight up going to use this formula, right? So I noticed that r is 1, which is great because the nth roots of 1, sweet, nth root of 1, doesn't matter what n is, the square root of 1, 1, the next root of 1, like every root of 1 would be 1, right? So the 6th root of 1 is going to be 1. Okay, so what I want is I'm going to find all 6 of these. There are going to be 6, right? So the first one is going to happen when k is 0. And in fact, what I'm going to do, because we don't need all of this essay that's at the top, is I'm going to start walking you through this. So we're essentially doing this 6 times. We're doing it, the first time we're doing it is when k is 0, right? That's going to be my first root, okay? So if I plug in k is 0, right, into this formula, I already know, so the good news is that r is 1, so this nth root of r is going to be a 1 it's a 1 every time anyway. So I'm going to get that this is a 1 times the cosine of, well, when I plug a 0 in here, my theta is already 0, right? So in this situation, my r is 1, which means for the record that the 6th root of 1 is also 1, so that's super awesome, right? And my theta is conveniently 0, right? So my theta is 0, so that's great. So when I plug in here, I'm going to get 0 plus 0 because k is also 0, so it turns out that I'm going to get that this is actually the exact same number I started with, which is going to feel weird, and you're going to be like, oh, hey, that's not a theta, it's a 0, my bad. So that's going to feel weird, but that's your first answer, and it's just going to end up being a 1. Great. When I plug in k is 1, right, I'm going to get, this is a 1, because again, it's the 6th root of 1, times the cosine of, well, when k is 1, remember, my theta is 0 here, so it's just going to be 2 pi over my n, which is 6. And I didn't bother to mention that this was 0 over 6, but it is over 6. So I'm going to get a 2 pi times 1 over 6. Well, that's just a 2 pi over 6, which is a pi over 3, right? And once I figure it out for the cosine, it's the same number for the sine, because that's the way the formula works. So if I clean this up using my knowledge of the unit circle, right, cosine of pi over 3 is a 1/2, so I'm going to get a 1/2 plus a root 3 over 2 times I, and that's the second root, right? The third root, when k is 2, is going to be that 1 times, well, now k is a 2, so this is going to be a 4 pi over a 6, which is the same as a 2 pi over 3. So cosine of 2 pi over 3 plus I sine of 2 pi over 3. Cosine of 2 pi over 3, it's the same point, it's the same 1/2 and a root 3 over 2, but now you're in quadrant 2, so it's going to be a negative 1/2 plus a root 3 over 2 times I, right? So I'm going to give myself a little more space, and remember, I'm going up until I hit k is 5, right? So when I do k is 3, right, we do k is 3. This is a 1. It's going to be cosine of 2 pi times the 3, which is 6 pi, right? 6 pi over 6 would just be a pi, plus I sine of pi, right? And again, if it helps you, you can look at where these angles are in a unit circle. So if I just inch this over a little bit, right? The first one, the angle was at 0, which is here. The second one, the angle is at pi over 3. The third one, the angle is at 2 pi over 3. Now my angle is at pi. Well, that's just going to be the point -1 comma 0. So I'm just going to get a -1 here, right? Then I'm going to do k is 4. Remember, I'm going up to the sixth one, which will be when k is 5. So 1 times cosine of, this is going to be a 2 pi times 4, which would be an 8 pi all over 6. So that's a 4 pi over 3, plus I sine of 4 pi over 3. Which again is the exact same point as these two other points. It just happens that this one is in quadrant 3. So I'm going to get a -1/2 minus a root 3 over 2i. Because again, it's that same spot. It's just the one that happens to be in in the third quadrant. And then the last one is k is 5, because again, I should have 6 of them, and I started at 0. And when I do k is 5, I'm going to get that this is a cosine of a 10 pi over 6, which is the same as a 5 pi over 3, which is not a huge shock because it's the fourth one of these pi over 3s, and there are 4 of them, and we just hit all of them. So I'm going to get that this is a +1/2 minus a root 3 over 2i, and that makes sense because this is the answer that's in quadrant 4, right? So it turns out that if I wanted the six roots of the complex number 1, right, I would get these 6 roots. Those would be my answers. 1, 2, 3, 4, 5, 6. 6 roots.